Okay, so just a reminder, in case you haven't been paying attention for the last couple of weeks, your test is next class. Today we're going to go over questions on our review packet, and then we'll actually start the next unit, Unit 2, Lesson 1, and go and put away phones, ladies. Thank you. We're going to start our next unit, the first lesson, and then next class is our test. Now, the lesson we're learning today is for next unit, so it's not on your test next class, okay? But we don't want to lose time by taking an extra day to do a little bit of review, so that's why we're starting on the next unit. So what we have for today is we'll go over questions we have on the review packet. You will get back your quizzes. We'll go over most common mistakes with that. And then we have our notes, and that's pretty much it. Your homework for tonight, take a look at your homework for tonight. What does it say? Additional review. Additional review. So what we're learning today is not what your homework's going to be on tonight. Your homework tonight is still just a little bit more review to help you prepare for the test. Next class, so after the test, you'll have homework dealing with what we did today. But I want you to still keep preparing for that test. The additional review, the key for that is on Blackboard, just like this review packet was. It is not as long as this review packet. So make sure that you ask questions. So check your answers with the key on Blackboard. Any remaining questions you have, make sure you come ask me before class, because next class, once you come in, you'll turn in your homework stamp sheet and we start the test right away, because I want to give you the whole 90 minutes for that. So make sure you come ask me questions before school, after school, stop by sometime in between classes if need be. But the key is up on Blackboard for you. Yes.
So is it next week or this week?
What is today?
Wednesday.
So Friday is your test. Yes. Okay. Other questions with that? Okay. So let's take a look at the questions we have up here. Number 8. You'll notice I put the notes, study this. Guaranteed you will have this on your test. We had it in class, you had it for homework, you had it on a quiz. You will have it on the test. Everything that was on your quizzes will be on your test, so make sure you know how to do it. So it says find the endpoint when we are given one of the endpoints and the midpoint. Okay, so we have to use our midpoint formula. But the difference here is that they gave us the midpoint. So our midpoint, which is 3, 3, equals our midpoint formula. Am I adding or subtracting my x's? Adding, good. A couple of us did not. Make sure you are adding your x's, you're averaging them. So it would be 3 plus, I don't know the x, and then 2 plus, I don't know the y, divided by 2. So my midpoint, 3, 3, equals the endpoints added together, but I don't know what my endpoints. And this is just 2 equations in one. So I take my x of the midpoint, which is 3, set equal to the x equation. I'm going to do the same thing for my y. Let's take my y at the midpoint, which is 3, put it into my y equation, or set equal to my y equation, and solve. Now, on the midpoint on our quiz, there were 2 common if you made a mistake, these were the 2 possible options. Either you had your formula on in the first place where you instead of adding, or the other common mistake that I saw. When you're solving, this is just an algebra mistake, so it's easy to fix. When you're solving, I personally like to go ahead and just multiply by 2 quickly. So I have 6 equals 3 plus x. Subtract my 3 and I get x equals 3. Some of you were going ahead and dividing your 2, and that's fine. But the mistake that was made is that you didn't divide everything by 2. So what we would have is 2 divided by 2 equals 1. And then we have to do y divided by 2. Some of you weren't dividing your y by 2. So you have to divide every term on top by the denominator. And then we go and subtract our 1s. We get 2 equals y over 2. Multiply by 2. We get y equals 4. It doesn't matter which way you solve it, as long as you solve it correctly or using proper algebra, you will get the same answer. So just be careful if you choose to divide that out, you should divide it. Okay, so our final answer then was 34. Questions with number 8? You will see that again. Okay, let's go ahead and go to 21 and 22 on this first page. right, 21 and 22. So the answers could vary. For 21, it says 3 non-collinear points. So you cannot draw a single line through all 3 of them. So you're going to need to have C or D to help ensure that it's non-collinear. If you said AEB, it's obviously the line there. So you would want to do like AEC, AED, DEB, ACD, ABB, BCA, any of those. So 3 of them have at least C or D, and then other 2 will help ensure that it's not collinear. Now for non-coplanar, you need to have both C and D. So again, non-coplanar ensures that no one plane can be drawn through it. If you just simply said AEBD, the reason why that's not going to work is because you can draw the plane that goes through that line, and then, because those are collinear, you can draw the plane that goes through that line and then just matches up to D there. So having D and C, again, helps ensure that when you pick your other 2, since no 3 of them are collinear, and that will help distinguish your plane. So you needed to have both C and D, but then you could have had A and E or A and B. So a couple options for that. Questions with 21, 22? Say that again? Yeah, there could be a vertical plane. Alright, oh wait, it's 4 non-coplanar points. I think I was thinking 4 coplanar points. Alright, hold that thought. Let me think for a moment. I just see I feel like we need to have 5 though, right? Katie, what are your thoughts? You were raising your hand.
The thing is, I think the AECD would work is because like we can draw a plane probably through C and and draw through A.
Right. These 3 would be on the plane, D would not be on the plane. Right. Okay. I go back to, I stand correcting myself, thinking I was going to correct myself. I stand with my original answer. These CAE are on the same plane, D is off of it. You could also say ACB, that is on the same plane, D is off of it, so you can't curve that though. Alright, other questions on the first page before I move on to our number 18. Okay, number 18. No one wanted number 15? Are we all okay with number 15? Little throwback to Algebra 1. There's the very first day of Algebra 1. So I'm teaching Algebra 1 this year. Literally the first day of class, we did this type of problem where you had to translate what 5 less than 4 times the measure of angle n is. So we didn't say measure of angle n, but 5 less than 4 times the number. Does anyone want 15? Okay, sweet. Let's do 15. Okay. What does it mean to be supplementary? Add up to 180 there. So I know that n and m have to add up to be 180. So the measure of angle n plus the measure of angle n equals 180. Add 186, it's supposed to be 0. I poured into the smart board, but it's not listening to me. Alright, now they did tell us the expressions in math notation. We had to come up with it. It says if the measure of angle n is 5 less than 4 times the measure of angle n. So I have 5 less than. Less than means subtracting, but we have to swap our orders. So I have 5 less than 4 times the measure of angle n. So I have 4 times the measure of angle n minus 5. So this is 5 less than 4 times the measure. Now you could have written it out like that, where you have measure of angle n. I just went ahead and called this the measure of angle n x, just to make life easier. You didn't have to do it that way, but that way I didn't have to write measure of angle n over and over again. So, with that being said, measure of angle n is 4x minus 5, so that's just 4 times my angle n minus 5. And then I called measure of angle n x. So that's where my equation came from. Solve, we get x is 37, but they asked for the measures, not just x. So you have to substitute back and get those. In the end, make sure your numbers actually add up to be 180. If not, then you know you messed up. Now it's equal to 18. Thank you for indulging me with 15. Okay. For number 18 here, so on our quiz, when we dealt with our segments being bisect and whatnot, if you got it wrong, most likely what you did is you just took the two expressions and added them together. Just because they give you two expressions does not mean that they're equal. That is the difference with geometry. Algebra, they gave you the equations. You solve them. Geometry, you have to decide what the equation is. So for 18, they gave us AD, this whole thing, which is 6x minus 4. And AC, just this, is 4x minus 3. If you just set those equal to each other, then what you're saying is that half the segment is the same length as the whole segment. And that's not possible. So just because I have two expressions doesn't mean that they're equal. You have to think about what they have given you in this situation. What I do know is that AC and CD are equal. They're congruent. So if this is 4x minus 3, so is this guy. And I know the whole thing is 6x minus 4. So you have a couple of options of how to set this up. So I know the whole thing is 6x minus 4. I know I have 4x minus 3 is half of it, so you can do 4x minus 3 plus 4x minus 3, or just double it, either way. Your other option would be that you could say 4x minus 3 equals half of the whole thing, 6x minus 4. Totally up to you. Either way, you'll get the same result. So when you solve, you get x equals 1. Substitute it back in. They didn't give us an expression for CD, but what is CD congruent to? AC. Well, we had the expression for that, so substitute it. We get AC, which is CD. So again, I cannot stress that enough. Whenever you have two expressions, don't just automatically set them equal. You're probably going to be wrong half the time if you do that. Look at what information they've given you. Do you need to double something? Do you need to add something together? Do you need to cut something in half? Take a look at what information they've given you. Okay, questions with 18 or any other last minute questions we came across from looking at our review? Okay, awesome. Okay, I still have. So let's take a look at 19 and then we'll get started with our notes. Okay, so 15, we have this diagram here. We've got some vertical angles. What do we know about vertical angles? What are they? We've got some options that make the x. Good. What else? So vertical angles are not linear pairs. But when we have the x, I could say 3 and 4 are linear pair. Who can give me a set of vertical angles in my picture? 2 and 4. So vertical angles in this situation are not necessarily linear pairs. Vertical angles are not ever linear pairs. But we do have, when we draw the x, if you take one vertical angle from one set and then the other angle is going to give you a linear pair. What else do we know about vertical angles? They are congruent. Good. So vertical angles are congruent. That's our vertical angles there. Yes.
Well, the angles add up to 360.
Yeah, so if we were to take all these angles, it would add to 360. Okay. So knowing vertical angles are congruent, let's take a look at 15. It says the measure of angle 2 is 95 degrees, which automatically means 4 would be 95 degrees. Now they didn't ask for that. Alright, so then it says, what is the measure of angle 1? Angles 1 and 2 are linear pairs, which means they're going to be supplementary. Just subtract that away, that's how we get 85. Linear pairs, are they supplementary or complementary? And are they always going to be supplementary?
Yes.
Yes. Are supplementary angles always linear pairs? No, they're not always. So sometimes they are, sometimes not. Remember, supplementary angles only have to add up to 180. They aren't necessarily next to each other. Linear pairs have to be next to each other. Okay. All right. So what we have for today, our lesson, our next unit, kind of takes a different branch in geometry. So we've learned a lot of vocabulary and some terms and definitions and theorems of postulates. And our second unit kind of takes a pause from that. Our second unit is logic and reasoning. So we're going to kind of take a pause from all of our beginning of geometry vocab and talk about if-then statements. If it is hot outside, then I will not wear a coat. So that's kind of what we're going to be taking a look at today. There's obviously more to it than just that. But you'll notice that we aren't necessarily using much with our vocabulary here. We will talk about if-then statements using our vocabulary. But we'll pick up more so with the geometry topics while picking up in parallel here. Oh my goodness, I completely forgot about homework. Because what I was going to have you do is check together some friends. So if you would, go ahead and shoulder partner check homework. Give them the assignment sheet in your review packet. Give them a score out of 10 with your initials next to it, where it says review. Thank you. That is very important. And one more. That is Is there anyone else that did not get the notes? Hey, you're doing that did not get the notes. Let's start. Okay. So again, like I said, our unit 2 is kind of a side road of geometry. So it's logic and reasoning. So we will use our logic and reasoning with our notation and our vocab that we learned. Like we'll talk about geometry within it. But this is not specifically lines intersecting, planes intersecting, over the again. So what we have are conditional statements, which are simply if-then statements. So a conditional statement is an if-then statement. And we use these all the time when we're talking. Now, when we talk in English, sometimes we don't use the words if-then, but it's still an assumed if-then. For example, here at noon, the bells will chime. You don't see the words if-then, but we can go ahead and put it back into that format. If it is 12 o'clock, then the bells will chime. So it's an if-then statement, just we don't always say that. Also, sometimes we don't always start off if yada yada, then yada yada. For example, our third one here, I will go shopping if I get paid today. So if we were to rewrite this, you would write, if I get paid today, then I will go shopping. So it is an if-then statement, just, again, in a different format. Whenever it's not in that if-then format, I highly recommend that you first rewrite it in the if-then format, because if you don't, then you're most likely going to get it wrong. There you go, there's an if-then statement. Okay, so with our conditional statements or if-then statements, with our if-then statements, we have a hypothesis and a conclusion. The if part is the hypothesis, and the then part is the conclusion. So for this example here, it's what comes after the if, it comes after the then. If it rains, then the football game will be canceled. Our hypothesis is it rains. Notice I don't take the if with it, it's what comes after the if. So our hypothesis is it rains. What's our conclusion? The football game will be canceled. 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 So nothing earth-shattering here. Now, we do have mathematical notation to help us represent an if-then statement. The mathematical notation we use is P arrow Q. We read this as if P, then Q, where P represents the hypothesis and Q represents the conclusion. You might also hear me say P implies Q, so that it just means the arrow in one direction. This helps us out when we have statements that are more complex than just an if-then. We can, of course, make this more complex, like if it rains and lightnings and it's too muddy, then the football game will be canceled and everyone will be sad, but not the people that didn't want to be there. Okay, so that was a really long sentence, multiple pieces to it. So we can give each component a letter. We can use different notation. The arrow indicates if then. We have a notation for not. We have a notation for and and or. We'll talk about that more later. So this is just notation to represent it. Okay. So hypothesis, what comes after the if. I'm just going to go ahead and circle it up here. What would our hypothesis be for our first example? Yeah, so our hypothesis would be the 12 o'clock. If we were to rewrite this in if-then format, if it is 12 o'clock, then the bells will chime. So our hypothesis is it is 12 o'clock. Okay, so again, rewrite it. So that's our hypothesis. And then our conclusion would be the bells will chime. That's our conclusion. For sake of time. For our third one here, looking at it in the if-then format, what would my hypothesis be? And by conclusion, I'll go shopping. Okay. You would actually write it out on an assessment, but we can take time to look that. Okay, so we have if-then statements, and we can take variations of that. So a variation is converse, another variation is inverse, and the last variation is contrapositive. These are all possible scenarios with it. So we start off with a conditional statement. That's our if-then. P implies Q. That's our original conditional statement format. And then we can manipulate it to get our converse, inverse, and contrapositive. The converse is simply that we switch our hypothesis and conclusion. Converse, we switch the hypothesis and conclusion. So in notation, we're literally just switching. Again, P is our hypothesis, Q is our conclusion. We're switching it. So we would have Q implies P. An example of this, if we just stick with our shopping example right above it, if I were to write the converse of this statement, it would be, if I go shopping, then I got paid today. Now our inverse is where we go back to original conditional and we negate the hypothesis and conclusion. Negate the hypothesis and conclusion. What does that mean, to negate? What does it mean to negate something? It's kind of like ignore, yeah, to the opposite of it. Now, our keyword for negated is going to be not. Okay, so we're going to put not. For example, to negate this statement up here, I would say, I did not get paid today. If our example where it said, talk about the rain and the game being canceled, if it does not rain. So you don't want to try to go with the opposite. Like, you don't want to say, if it's sunny, then the game won't be canceled. You want to just put the word not in there. Because there's different situations, right? It could be that it's not raining, but it's snowing, you know. So you don't want to try to do the opposite. You want to just put the word not in there. Our notation for not is this little squiggle that looks like this way. So when we do our inverse, again, we're negate. So we go back to our original conditional. We would have not P implies not Q. So for our shopping example, if I did not get paid today, if I do not get paid today, then I will not go shopping. All right, our last variation is contrapositive. Contrapositive, we're simply doing both. We're going to switch and negate. We will switch and negate. Both the hypothesis and conclusion. So you're doing the inverse of the converse, or the converse of inverse. You're doing both of those. So again, we go back to our original conditional. We're going to switch and negate. So that would be not Q implies not Q. So again, going to our shopping example. If I do not go shopping today, then I did not get paid. So you switch and negate. So these are the variations you can do with your conditional statement. Now, just because my conditional statement is true doesn't automatically mean that the others are also true. Okay. So let's take a look at an example of these, and then we'll talk about how we know if it's true or not. Okay. So here's our example just to practice inverse, converse, and contrapositive. If you are a student, then you have lots of homework. You guys agree with that? Yeah. You guys have lots of homework. You have a lot on your plate. So unless you're taking all gym classes, I bet there's not a lot. Did they ever give you homework for gym class?
No.
In health, do they?
Tiny.
Maybe it should be a gym teacher. Okay, you wouldn't want me as a gym teacher. I would make you run miles over and over again. If you're a student, then you have lots of homework. So our converse, we just switch. First of all, make sure it's in the if-then format. That will make your life easier. And again, we are only switching our hypothesis and the conclusion. We're not switching the if-then. Okay, so our converse, switch. If you have lots of homework, if you have lots of homework, then you are a student. Pretty easy, right? All right, inverse, we are negating. Again, go back to your original conditional. If you are not a student, if you are not a student, then you do not have lots of fun. And you do not have lots of fun. All right, and then our contrapositive. So the inverse, another way you might hear me phrase it is we're negating the if-then. That's inverse is negating. Contrapositive, we do both. So contrapositive, if you do not have lots of homework, then you are not a student. So we switch and negate. If you do not have lots of homework, then you are not a student. Okay, so like I said, if the conditional is true, that doesn't automatically follow these other ones are also true. But we do know that if the conditional is true, guaranteed that the contrapositive is true. If the conditional is false, the contrapositive is false. So they're kind of married. They're the same thing. They're either both true or both false. They have the same truth value, either both true or both false. The conditional and contrapositive are married together. They're either both true or both false. Interestingly, converse and inverse are also married together. So converse and inverse, same thing. Either they're both true or both false. Now, they don't have to be the same as the conditional. So you could have conditional, contrapositive, or true, inverse, converse, or false. But they have the same truth value. This is helpful to know because sometimes we'll get a statement that's not a simple if-then. There might be some nots in it, or it might just be kind of confusing to think of it. So if my original my original conditional I have, I'm not sure if it's true, I can write the contrapositive of it, and if I know the contrapositive is true, then the conditional has to be true. Same with if I'm given the or if I'm given the conditional and they say, is the converse true or false? And you write out the converse, you're like, I'm not sure. But when you write the inverse, you know for a fact it's true or false. Then you know the converse will be the same. So they have the same truth value. Conditional, contrapositive are married together. Converse and inverse. Okay. The backside here is just a lot of examples. I'm not going to just go through it all at the same time. When you're writing your inverse, converse, contrapositive, you do have the freedom to slightly adjust things so it makes sense grammatically. Like you might have to slightly adjust the wording or slightly adjust the text. Kind of like I did with the shopping. Kind of like I did with the shopping example. If I do not get paid today, then I will not go shopping. You could have said, like, if I didn't get paid today, then I didn't go shopping. So slight variations just to make sure it makes sense grammatically. Try to keep it as true to the original words as possible, but if you write the converse, you need to adjust it slightly, that is possible. Okay, so next let's take a look at our, go back. Okay, so let's take a look at our by condition. Now our by condition we briefly talked about in our class. So this top part is just talking more about the notation we just did. Okay, so P and Q are symbols. This is notation for if, then. If I drop the hammer on my toe, then it will hurt. And we have this to indicate not. Now, like I said, statements are not always a nice, beautiful P implies Q. So make sure you are able to do the variations, inverse, converse, contrapositive, on any kind of form. So let's take a look at this example here. Here, my original conditional statement would be not P implies Q. Right? So when we do our converse, we're still just switching. The not travels with the P. So when I do my converse, it would be Q implies not P. Okay, we just switch. When I go to do my inverse, we are negating the original. What is negating not give us? Not P. If I negate not P, what does that give me? P. Yeah, not P, so it's just P. Right? So P implies not Q. So just because you have inverse doesn't mean you're going to have not. You have to go back to your original. Then our contrapositive, we switch and negate. So not Q implies P. You can really just take your inverse and switch it, or take your converse. So an example of this would be if it's not my book, then it is someone else's. So converse would be if it is someone else's book, then it is not mine. Inverse would be if it's my book, then it is not someone else's. Contrapositive, if it is not someone else's book, then it is mine. Okay, so this is just an actual sentence example. All right, biconditional. Biconditional is an if and only if statement. What this means is that it's true both ways. P implies Q, and I also know that Q implies P. For that notation, we put this little double arrow here, which means it's true both ways. So I would read it as P if and only if Q. If P, then Q, and Q, then. So in order for that to be true, both the conditional and converse must be true, which makes sense because the converse is switching it. So if the original is true and the switch is true, then it's true both ways. So you can go to the mall if and only if you clean your room. So in other words, if you clean your room, you can go to the mall. If you went to the mall, then you cleaned your room. So it's true both ways. Okay. You can see that we apply this a little bit with our math. Like for example, down here, the statement if x equals 3, then x squared equals 9. Would you guys agree that that is true going this direction? If x is 3, x squared is 9. Is it true going backward though? If x squared equals 9 and x equals 3. No, why not? What would x be? Positive. Good, positive, negative. So this one would be an example we cannot write as a biconditional because it's not true. All right, your homework for tonight, again, it's just additional review. The key is up on Blackboard. What we learned today, this new logic routine is not on your test. You will have homework on it next class. But your homework is this review. Be on Blackboard. Make sure you come see me with questions before next class. Oh my God. What you're reading right now. Oh, you mean finishing the notes. Guys, you don't need to finish the notes unless you really so want to. The rest is just examples. If you want to try it on your own, you will have homework on this, so. Alright. Any questions? Alright, so again, make sure you do this additional review, know it all for your test. Come see me if you have questions lingering on the review, on your quiz that you can't figure out. I am after school today and tomorrow. I'll just be gone for the first few minutes tomorrow after school, but I'll be here if you need to come ask me questions.
Will they give you an extra charge if you flush it?
Will they give you what? What?